Hello everyone, my name is Elijah Proctor, and today we're going to be talking about advanced hypothesis testing. Our second task is to perform an analysis on multiple population means. So we must first find a suitable data set, and so we're using this wine quality data set, and primarily we're going to be looking at our alcohol column and our quality with a score between 0 and 10 for our analysis. And so what we're doing today is we're going to be analyzing the differences in alcohol content among wines with different quality ratings, and we're using this wine set data set to do so that has various chemical characteristics of wine. And so our goal is to determine if the average alcohol content differs significantly across these quality ratings. We employed a one-way ANOVA for this purpose, as it's suitable for comparing means across multiple groups. So let's quickly go through the code. So we first read the CSV, so we load the data set, then we extract relevant columns. So we have our alcohol and our quality columns from our data set, and then we're going to group the data by quality by performing this simple computation, this for each loop, and finding our unique qualities, and then storing them inside this groups variable. And then using this, we're going to perform a one-way ANOVA. So we're just going to pass in our groups into our F one-way function, which gives us our F statistic and our p-value. And then we're going to perform a test for normality within each group. So we're basically going to loop through all of our unique qualities, and then we're going to perform our Shapiro-Wilk test, and then we're going to return our p-value. And so we're going to print this for every single unique group, and then we're going to test for equal variances. And so we have using our Levine test. So we call our stats.levine, pass in our groups. This returns our stat Levine and our p Levine values. And then we print those out. And then we plot our box plot for our alcohol content by wine quality. And then our QQ plot for every single group. So we're basically going to loop through our quality or all of our unique qualities, and then perform a prob plot on those. And so let's look at our results that we have here. And so here we analyze the differences in alcohol content among wines with different quality ratings using our data set. And so our goal is to determine if the average alcohol content differs significantly. And so what we have here is we have our ANOVA test, which revealed a significant difference between the groups. Our F is equal to 82.74, and then we have a really small p-value, and this indicates that the mean alcohol content varies significantly depending on the wine's quality rating. Our Shapiro-Wilk test for normality was performed on the residuals for every single quality group with mixed results. So we have our p-values that suggest some groups. So we have quality 4 and 5 that deviate significantly from a normal distribution, and then we have other groups, our quality 3 and 7, do not show significant deviations from normality. The QQ plots do further illustrate this. So we have groups like Q, quality 3 and 8. So we have quality 3 and then 8 here that show points closely following the line, and this indicates normality. And then we have groups like 5 and 6 that deviate more from the line, and this indicates non-normality. We have our Levine's test for homogeneity of variances, and it returned a very low p-value, and this indicates that the variances across the quality groups are not equal, and this violates the assumption of equal variances, which is crucial for the validity of the ANOVA results. Our box plot here for alcohol content by wine quality shows the spread of alcohol content for each quality group, with high quality wines generally having higher alcohol content. However, There is noticeably variability within and between the groups, with some outliers present, especially in the medium quality wines. So let's go over our analysis here. And so our results showed a significant difference in alcohol content across different quality ratings. So our F statistic was 82.75 with a very small p-value, and this suggests that the wine quality has a notable impact on average alcohol content. However, to ensure the reliability of these results, we must conduct additional tests. So we have our Levine's test for homogeneity of variances and our Shapiro-Wilk test for normality within each quality group. Our results reveal that some groups, particularly those with quality ratings of 4, 5, and 6, do not meet the normality assumption, and the Levine's test indicated a significant violation of the equal variances assumption. Given these violations of ANOVA assumptions, especially the issues with normality and equal variances, we should consider alternative approaches such as Welch's ANOVA, which would help ensure more accurate conclusions. So, our study highlights the importance of checking assumptions and hypothesis testing to avoid potential errors in interpretation. Thank you for listening. That is all.